what it computes is the standard error and the 90% confidence interval. The other thing that I wanted to do with these results is show what the sampling distribution looks like. So when the sampling size is 100, the standard error is about 1.6, and the confidence interval is that. If I go back out confidence interval, the width of the confidence interval got smaller. To see that graphically, we can interact with it. So here's n equals 100. As I crank up the sample size, the sampling distribution gets narrow, the standard error gets small, and the width of the confidence interval gets small. As the sample size goes down, it's the opposite of all of this. Good? Questions? Yes. What does the confidence interval actually mean? Let me come back to that one in a minute. It's a great question. It's the question of the 21st century. Okay. Now, one nice thing about this framework is that we now have a way to compute sampling distributions for anything that we want to measure. So far, I've been talking about the mean adult weight, but we could use this to compute the sampling distribution of anything, like the min, or the max, or the median, or the standard deviation. So let me do that one. I'm going to copy this cell. So I can take all those functions that I just used, the ones that do all of this random sampling. The only thing I'm going to replace is this function called samplestat that just says if you give me a sample, I'm going to compute its standard deviation. So this is like I'm going to run a bunch of experiments. For each experiment, I'm going to compute one estimate of the standard deviation, and then I'm going to plot the distribution of those estimates. And what this says is that I think that the standard deviation of adult height is about 16 kilograms, but my standard error is about 1.4, and I have a confidence interval from about 14 to about 19. And if you did the exercise, did you try this out with a couple of different statistics, we can compute a confidence interval for anything that you want to measure using this framework without making any changes. And I point this out partly because if you try to do the same thing mathematically, it gets really hard really fast. Computing the sampling distribution of the mean, easy. Standard deviation, harder. Median, quite hard. Interquartile range, very hard. Whereas computationally, we don't care. If you can compute it, I can tell you the confidence interval.
course the antenna. Then you need to lift the knob, and then the antenna socket, and of course here our switch is normally fixed here by something like this, which will hold it in, and then you have very often two screws which you have to take out, and normally then it should be relatively easy to lift it here out of the housing. And yeah, so you see it is coming, it is really coming up, but now yeah, you have to wiggle it very, very carefully, a little bit back and forth, and normally we should be able to pull it here out. So here is another washer, that is fine, and yeah, so here we have the rubber seal, and I've already disconnected here the ribbon cable. So yeah, let me take the camera out of the way to get a little bit closer into our radio. Now here we can see that we are missing a little connector to disconnect here our speaker wire, so it is simply soldered here, this speaker, to our main board, and I have now to lift off our display board. So that is what I try to get off, because maybe something is wrong with our display connection, so that is what we need to check, and therefore I try to get this PCB out of the housing to do, or to be able to do a better inspection. But before we go ahead, I recognized that the ribbon cable over here is not really in its connector, so it looks to me that it is really canted. So let's try to align it a little bit, maybe that this is already the problem. Okay, so I have corrected here our ribbon cable, how it sits in its connector, and of course for testing, can we see it here? Maybe that way. It's a little bit dark. For testing, I have of course here our ribbon cable, our second one, connected back to the display board, and now only for testing it is easy to put it here on, and yeah, let's see what we have. Hello! Yeah, so it is back. So my assumption was definitely right. It really lost its connection in the socket, so that was the whole problem. And I've heard it quite often that it happened to radios like this, and now we can be sure it is not really a serious problem. It is not an expensive fault. It is simply the little connector here in or on the display board. And of course I was interested in the question if this little connector down here is or has really good solder work, and I can definitely say that all the connections, all the solder work down at this connector down here is excellent, so we really do not have an issue down there. It is definitely only this ribbon cable. It is a little bit short, and maybe if the handheld is placed to different temperatures, or if it fell down or whatever, so maybe that it get its connector. So that might be the reason why it lost connection. So everything else is just fine. I will now bring it back into original condition, and then that should be fine. And if it is working, then you know how you can fix this issue. Alright, so it is back in its housing, so I only need to put back here all the knobs and our antenna, of course, and here the belt clip and so forth. But basically you see, it is definitely back working, and very important when you put it back together, don't forget the rubber sealing. That is very important, that not any water is getting into it. I mean, it is not waterproof, but if you're outside in the rain or what have we, then it is definitely good to have this rubber sealing. So don't forget to put it back. And now let me assemble here the rest of what we need to do, and then we are ready. Okay, that's it, already the end of the video. So that is the widescreen solution for TYT, Retevis, or however these radios are called or named. So that is a widescreen solution, and I hope that is something what can help you out in the same way I've done it here. Okay, thank you for watching, and catch you next time. Bye.
また来たか、大阪。まずはチェックインか。よっしゃ Thank you hotels.com。 これでもう一晩大阪で過ごせるぞ。
あら、ダンディさん、出張でまた大阪来はったんですか？
今月はこれで10泊目です。
ほら、あれよ、ゲッツやね。
あれ、今回の宿泊で何かあるというのか。この大阪出張の中に何かありそうだ。あー、広いベッド。これは家のベッドよりも居心地がいい。なんだか急に腹が減った。大阪は賑やかだ。この活気、不思議と孤独に感じない。何を食べようかな。
ちょっと、そこ何ぼーっと突っ立ってんのよ。あ、お腹空いてんねんな。
あげちゃんあげよう。ちょっとやないやろ。ジョークやがな、ジョーク。もう兄ちゃんが構える、うちらが打たれる。お腹空いてんねやぞ。とこあんねん、知ってる私。行こう行こう行こう。行こう行こう行こう行こう。
10杯飲んだら1杯無料か。いいなあ、欲をそそる。あ、いかんいかん、仕事で来てるんだった。雰囲気に飲まれるな。
まずはビール。
それにしてもみんな楽しそうだな。この活気と笑い声がなんかうまい。あれ、いつどうやって帰ってきたんだ。それにしても昨晩の楽しい時間を覚えていないなんて悔やまれる。もう一泊できたらな。よっしゃー、ホテル.com。ホテル.comで一泊分の無料宿泊を
Hi and welcome to Xbench. Well, over the time I had a lot of requests if I could show how to test a receiver, and yeah, that is what I try to do today with very first video on testing a receiver. And well, let's start with the easiest way to test a receiver, because you know, for testing a receiver the only thing you need is a signal generator and an audio voltmeter, and with this both instruments you are already able to test for signal to noise. And yeah, let's start with this easy testing and how we have to connect, you know, the radio and the test equipment.